Hello everyone. Today I'm decided to show you this solution for this confusing number and confusing problem. So first we'll discuss what the problem is and some just to figure out what the description, what we have to do. Then I decided to show you this tricks. So there are two tricks that help you out to resolve the problem easier than you might imagine, but anyway, it's really easy. And then I strongly recommend to memorize these tricks. Potentially in the future it will help you out to resolve many problems. And just the spoiler, this trick calls arithmetic concatenation. So let's consider the problem and try to figure out how can we resolve. So the problem about confusing number. So we have a sum number, so the sum given number, and we have no idea how many places or digits we have in this number. But 1 second, I take the some pen or pencil. Yeah. I don't know why, but I can do anything. Okay. We have some number, for example, like this example, we have a 6, and this example we have a 89. And the question is, we rotate this number, but there are a few nuances. The first nuances, we have some trick, not trick, we have some confusing digit, I would say. So for example, we have a 6, and this 6 can transform to 9 like this, and in the same can works opposite, like 9 to 6. So if we have a sum number and this number will be rotated, so we have to rotate every digits 6 to 9 and 9 to 6. Then we have to handle the leading zero. For example, if we have 8,000 and we rotate this number, so and we have a leading zero, and in our example we have to ignore this leading zero and consider this number without leading zero, just individual only 8, like as a one digit. Then we have some exceptions. For example, if we have 2, 3, 4, 5 and 7 in our given number, we understand that this number is invalid, because if we rotate 2, 3, 4 and 5, so we will get just not a number in decimal system, just something else. And the question sounds like this. So we give you the sum number, you have to rotate, after rotating you have to ignore the leading zero. 6 and 9 transfer to opposite, like 6 to 9 and 9 to 6, and then you have to return the answer. So is it possible to rotate this answer or not? And don't forget to handle these invalid digits. For example, if we have given some digits, so return false by default. And the question is, how can we do? I will show you the two. 1 second, sorry. I will show you two tricks which help you out how to resolve the problem, and it will I think it will be a great tool for next future tasks. So the first trick is removing rightmost digits from number. So what I mean. For example, let's write down here under my code. So for example, we have some number, for example 89, like in the second example in this LeetCode task, and we have 89 number. So how can we remove rightmost digit? For example, the first it will be 9 and then it will be 8. And how can we remove in the beginning? We remove here, or like here 9 and then remove 8, followed by this order from right side to the left side. Of course, we might to transfer our number to string, like 89 is a string, and consider this string as an individual char, and take this rightmost char, move to right to the left direction, and then take every char individually and do some transformation with this char. But the trick based on the arithmetic concatenation, and I will show you how can we do it. Use doing arithmetically. So how can we do it? Right, 1 second. I remove this line. Okay. The first step is use modulo operation. So and use the base of our decimal system. So we are use modulo operation, and always when we're doing modulo by 10, we always will have some reminder. Reminder is a last or rightmost digit or less significant digit in this particular number. For this example, it will be 9. So then it doesn't matter how big we have, but of course it's matter, but I mean it doesn't matter for basic algorithm, how wider we have this number and big. But if we have some number, so the modulo operation by base of our decimal system, particularly 10, so it will be last or more accurate rightmost number in this rightmost digit is this number. And then we have to somehow reduce this number and imitate the iterating from right side to the left side. So in the first operation, 89 modulo 10, it has a 9 remainder, and then the second step is divide to 10, and we have 8.9. So, and we have to truncate or floor operation just to avoid or remove the rightmost digit in this number, just to imitate removing. And because we are take this rightmost digit and now we are going to remove them from the number. So it depends on our programming languages, but for example TypeScript or JavaScript as well, it will be math truncate or the math floor. So in this case, both operation remove 9 from this digit. So the second step, this like enumerate this first step and second step. In the second step, we remove rightmost digit, and it means we reduce the numbers of places in our number from right side and just move to the left side. We are just to take next digit in this number. And the first step, we take this rightmost digit. Just we take rightmost digit. So, and we have to continue this operation until we reach the 0 and traverse all of the digits or places in this particular number. So the first, just write down the some head of algorithm. We take rightmost digit and remove it, and that's it. So we, in this operation, helps us out to remove the rightmost digit, put it somewhere and somehow, but to take one by one from right side to the left side. Okay. So the second trick calls put some digit to, or just not put some digit, concatenate some digit to number. So let's imagine we have some number, for example 1, and we have to concatenate, not sum up arithmetically, but concatenate like as a string. For example, we have to concatenate 2, and then it will be 12, just to put next to one digit to another. And arithmetically, there's operation multiply. For example, we have some digit, we multiply base our system, particular decimal system, multiply 10, and then plus the particular digit we have to add. This is a formula. And in our example, we have 1 multiply 10 plus 2. And it means we have a 10 plus 2 and 12 as well. What this example shows us that the operation of multiply 10 make wider of number, and it makes it's possible to add new digit because our number has a one place. So we have a 1 as only one place in this number, and then after multiply 10 we make wider, and now we have 2 places. We have 1 and 0, and we add extra place in the rightmost side 10, and our sum operation change the last or rightmost digit in this number, and will be transformed to 12. And for example, we have in next operation we have already 12. Just a reminder, we have a 12, and now we have to concatenate the 3. What we are doing? So 12 multiply 10 plus 3. It means 12 multiply 10 in 120 plus 3. It means 123. So we concatenated it. We use the next place from in the right side, and we concatenate it. So these 2 tricks help out to resolve the problem, because the rest of the problems with leading 0, invalid numbers, just nothing, because there's 2 keys of or 2 tricks of this problem. So let's consider how we are going to handle the leading 0. So use this trick with concatenation. We really don't care about the leading 0, because this concatenation algorithm will be handle this problem by itself. So how does it work? For example, we have a number, for example 89, and a few zeros. Then what will happen? We take the first step is take digit from rightmost side, and do something else, just reminder from first step. And we take this 0, and now we literally our hands are holding this digit. We have a 0, and now the next operation, we add the 0 to our answer. For example, we have some answer, for example, that our answer is 0, and like the base case, and we multiply our 0 to 10, then we are get 0 and plus 0. 0 is a, 1 second, I mark it. Well, 0 is this digit. We are take this one and this one and this one, like from right side to the left side, and now the first rightmost digit in here, 0, and we plus the 0 to this number. There's a base number of our algorithm, the base. But now it does happen at all. So we have a 0 again. Then we take the another 0 and to make the same operation, and will have the same. The third operation, we multiply 10 like as well, but now we'll take 9. Sorry, 9, and we will have 9. And the next operation, we already have a 9, multiply 10, and 90 plus 8, and we have a 98. So at the moment I'm demonstrating what will be do if we're doing with leading 0. So we multiply 0 to 10 just to make wider your number, and add in the last on the rightmost digit to the new digit, but because we have a zeros and zeros rotate to the leading 0, so after we multiply our base variable, initial value of our variable, we are plus and nothing happened. We just don't move anything, and then we are encounter with 9, and at this moment we start to make wider and increase, just concatenate every digit with our answer. So then we'll have a 98. But that is not on our answer, because we haven't finished yet. But the rest of the problem is really easy to resolve, because now we have all of the things we have to have, and just some middle logic to our algorithm. So the first thing we have to store somewhere, it depends on you, maybe set or map or even array, some invalid digits like here. And when we take when we make our first algorithm, first operation here, we have to check there is an invalid digit or not. If it's an invalid digit, so we have to return false immediately. And a few minutes ago we resolved how we are going to handle the leading 0, so it won't be a problem for us. Then the transmission or transitions, I would say, the operation. So we have to store again somewhere the 6 and 9, and when we come across with 6, we have to transfer the 6 to 9, and doing the same thing opposite. Like if we come across with 9, we have to take the 6. So that's it. And there is a eventual code. So we have some invalid numbers, and we have inverse numbers, just 6 to 10 and and 9 to 6. 10 I said, 9 of course. And then we have some digits. I'm not sure, it's probably all, yeah, this is all, well, not need. We have some rotate number, so it's our eventual answer. We are not going to return the answer, but we have to rely on this answer because we have to compare the old result and next result. Because some case, for example, we have 11, 1 and 1 digits, so if we rotate, nothing change, and we have to return false, because the question is, our task is after the rotating is possible, and will be this our number changed. And then we are copy our original number, the given number, in our argument, and just because we have intention to change the original number. And then a simple while. So we're changing those original number. What we are doing, these two operations which are shown before. We have a digit, so modulo operation helps out us to take the rightmost digit. Then after that, when we are already taking this digit, we are checked so this digit is invalid or not. So it's invalid, we return false. Then we have inverse nums. So if our taken number is 6 or 9, depends on the case. So if it means we have to change our digit. So for example, our digit is 6, we understand, so there is 6, it has a set of inversed, maybe it will be better name, but anyway, inverse numbers. So we have to change this inversed number, and doing the same thing for 9. Then we'll make concatenation. So in our base initial value is 0, so we are multiply 10, make wider a number, and plus the digit. It might be inverse digit, or it might be just simple like 8, but we are doing. So then we are doing and reduce or make thinner, if I might say, our number, and repeat this operation again and again until we don't reach this none equal to 0. And then the last step, we have to compare our calculated or concatenated answer with the original number, and if are not equal, so it means they are different and the answer exists. So it will be happen with example 2. We have 89 and then we have 68. It will be work for 6 because we are 6 to 9, this different number, but it won't work with 11 because nothing changed. This will be equal. In the same time, we are handling this leading zero by default by our algorithm I demonstrated before, and that's it. So all of the tricks which I am going to show you. And the last step, to talk about the time complexity. So don't pay attention at some I was ruminating about the problem, some more notes and thoughts about it, but let's consider the time complexity. So we might say this time complexity is O(n), but it's not like that. So we might say this time complexity is O(d). Then d is a number of digits in a given number. And more formally, it will be, say, a logarithm n, because the n is our given number. For example, if we have 89, so we have to make the logarithm base of 10, and so it's really hard to base 10, but anyway, logarithm 10 to 89, it will be 2 or some more, or maybe some period. I don't remember really. And it will be pretty close for our number of operation we are doing. So more formally, it's a logarithm n, and at the same time we might say this O of d, where the d is a number of digits in the given number. But the n is the given number by itself, so we might say there's an n, because the n is a given number, it's not a number of digits. So with the space complexity constant, so we don't increase in here and here, so we might say this is O1. And that's it. I think these two tricks will be a great tool for your next problems, and use and be happy with that. Thank you that you're watching my video, and bye bye.